Hi guys, I'm Suprabha. In the first video, we studied all the basics of probability, and then in second video, we studied what are events and different types of events. In this video, we'll move on to the terms called intersection, union, and additive rules or the addition rule for probability. Intersection, event containing all the elements that are common to both the events. This simply means, suppose there is an event A that consists of elements 1, 2, 3, 4. And then we have event B. It consists of elements 3, 5, 6. And we are supposed to find out the intersection of A and B. Elements common in both. You can see there is only one element that is common. So intersection of A and B will be one element, that is 3. This is also written as A and B. This intersection only means and. Union, event containing all elements that belong to A or B or both. We'll take the same example. Element A with these elements, B with elements 3, 5, 6. So, A union B, it says all the elements that are included in event A as well as in event B. So, that will be 1, 2, 3, 4, 5, 6. So, this gives us union of A and B, or this is also written as A or B. Moving on, addition rule of probability or additive rules. If A and B are two events, then P A union B, probability of A union B is equal to addition of probabilities of those two events minus intersection of probability of A and B. Now let us see what this means through a Venn diagram. Suppose this is sample space S and we have event A and event B. We'll take the same example 1, 2, 4, 5, 6. And as we know, 3 is common between both. So 3 will be written here. That is, it is included in A as well as in B. Now union will be why do we need to subtract the intersection of both? That means, suppose now the probability here is 1, 2, 3, 4 plus 3, 5, 6. Now if you see 3 comes twice, but in the union we need 3 only once. So to subtract this common element once, we are including this term, that is intersection of both the events. So minus 3 will give us total 1, 2, 3, 4, 5 and 6. Now this is about the two events A and B. If we extend this formula for 3 events, it will be A union B union C. Probability of each events, that is probability of event A, probability of event B and probability of event C. Now we are supposed to subtract the intersections. Now before that, we'll modify the Venn diagram and understand. As seen in the above formula, for union, we are supposed to add the sum of individual probabilities and then subtract the common elements. So this is the addition of individual probabilities. Now let us start subtracting the common elements. So if you see this part, entire is common in events A and B. So that will be subtracted. P A intersection B minus, again we have this part that is common in events B and C, and at the last this is the part. So probability of event A intersection event C. Now if you see this part, suppose this part consists of element 6 that is common for all the events A, B and C. Okay, but that is getting cancelled because of the intersection part. The 6 will appear thrice here in the addition of all the events, but will be subtracted in the intersection. So for the for the element to appear at least once, we need to add the common element of all the 3 events, that is A intersection B intersection C. What you do is you simply take an example that consists of various elements for A, B and C, solve using this formula and see if you get correct. If you still have doubt, you can ask in the comment section. Now, if A and B are mutually exclusive events, now mutually exclusive events are those events whose intersection is equal to 0 or null event. So the above formula will be modified as probability of union of two events is equal to sum of the individual probabilities, and will not have the third term because anyway intersection is equal to 0. So Venn diagram can be modified as, suppose this is event A and this is event B. They are having no elements in common. Similarly, this formula can be written for the 3 events as well. This is task for you. Let me know the answers in the comment section. Before we end, in last video we studied complementary event and mutually exclusive event. There is an important note that all the complementary events are always mutually exclusive events, but the contrary is not true. That is, all the mutually exclusive events may or may not be complementary events. Hope you understood. Thank you. Thank you for your support till now. We'll need it further too. So please like the video, share with your friends and don't forget to subscribe to our channel. Thank you.